So, in conduction and breakdown of pure liquid as well as in conduction and breakdown of the capacity commercial liquid. Okay. First, we have discussed the conduction and breakdown of the pure liquid. What you are using? You are taking a pure liquid without having any impurities. Whether the pure liquid be hexane, that is chemical formula for it is C6H14, or when we taking the pure liquid that is heptate, that is C6 or C6H16. Okay, in number of we all know quantity liquid that one we will be taking. Okay, pure liquid what doesn't has any impurities. For example, what I have told, out of 10 to the power 9, just one amount will be impurities will be there, which is uncommon, which is will not come in the compound itself. So we can get that pure liquid as a diluted. So what is happening there? Whenever the voltage is during the high voltage gate, whenever we are applying the high voltage, due to high voltage, what is happening? Electric field is increasing. So we have seen a graph with respect to how the electric field, how the direction of current is. Okay. So with respect to electric field, how is the current? Under three different ranges. First, when we are seeing at low field, it will be in the range of ionic region. You will see the current is due to the current is arising due to the dissociation of ions. Okay, when the electric field is low. Okay, so the second stage we are saying is the electric field is at saturation stage. Okay, so the electric field is in the intermediate stage. What is happening? Current is reaching its saturation stage. Okay, so after the third range is formed to be the high field range, and at this stage we are getting the field. What is that? It is get faded. Okay, so that's what we have discussed in the conduction and breakdown in the pure liquid. After that, what is happening in the voltage we are applying the density higher? What is happening? Electric field is getting increased. Electric field is getting increases. So the conduction of current is also getting increases. At a particular it reaches the third, that is high field range. The field are getting faded. At that condition, applied voltage is what? That is the breakdown voltage. Okay. So what is the purpose for the breakdown voltage? How the breakdown that is occurring depends on the pure liquid. It depends upon the what field we are applying. Okay, that is the applied field. Next, it depends upon what? It depends upon the breakdown of that is the gas separation. Okay, what is the time factor depends on? It depends on cathode work function. Okay, there is one cathode work function. Next, and the fourth is depends on liquid's viscosity and liquid's temperature, and one of that depends on what? Density and the molecular form of the structure of a liquid. Okay, these are the factors. In a pure liquid, we are using a pure liquid or dielectric medium. The breakdown occurs due to this 6 factors. Okay, so what is the basic thing we have learned that whenever the voltage is increases, current is getting increased. What is the reason for that? The electrons will getting multiplied. The current was getting increases due to the multiplication, or we can say that the electrons are generated in a larger number. Okay, so due to that, next what is happening? Due to the surrounding of the distributed in the air or gases like oxygen or N4, nitrogen dioxide, we have already seen that. Okay, so due to that, what is happening? Ionization process happening. Okay, so that is the initial and low field. What is the dissociation of ions? And the intermediate field, saturation region for current occurring, and high field. What is happening? Field area we are achieving. Okay, that is the conduction and breakdown voltage that is happening in the pure liquid. Now the next is conduction and breakdown that is occurring in the commercial liquid. Commercial liquid will have impurities. Okay, commercial liquids will have impurities. It is not pure. Okay, so what are the impurities which will present? Normal liquid, commercial liquid, what we are using is liquid water. Okay, so what is happening? What will happen there? It will have bubbles, or it will have any suspended particles. It will have some fiber like dust over there. Okay, so it will have bubbles or any suspended particles in it. Okay, so what is this? Impurities will reduces the breakdown strength. Okay, so what is happening is mechanism. Okay, so among that, the first one is suspended particle mechanism. Okay, so here the impurities as I already told. Okay, the suspended particles may be made of fibers also. Okay, so the impurities are either fiber or any other suspended particles, or you can say any other dispersed solids or dispersed waste. Okay, so here we have taken two things. One is our liquid's permittivity, and the other one is that impurities permittivity. So we have considered the liquid's permittivity as epsilon 1. Okay, and the impurities, or we can say that suspended particle, or we can say that dispersed solid, or we can say that fiber or impurities, whatever. Okay, so we are taking that permittivity as epsilon 2. Okay, so liquids forward we are saying permittivity of the liquid is epsilon 1, and the permittivity of any suspended particle or impurities we are taking as epsilon 2. Okay, so what is happening is we are going to consider the impurity. We are going to consider the impurities as a spherical sphere. Okay, we can write the question of impurity in spherical sphere. The spherical sphere is having a radius of r. Okay, impurities will be in spherical sphere and its radius be r. Okay, so the particle experiences a force. What is happening whenever it increases in voltages? What will happen? There will be an increase in force. Okay, it has to travel. The voltage has to transfer. Right. So the force that arises F is equal to based on the radius r and the permittivity of the liquid as well as the permittivity of the impurities. The formula for it is F is equal to, there is no derivation for you, just the formula. Okay, it is F is equal to 1 by 2 or Q will be epsilon 2 minus epsilon divided by 2 epsilon 1 plus epsilon 2. If we come to the permittivity of the liquid, permittivity of the impurity and the impurities radius r, what we can find out how much amount of force it is experiencing, we can able to find out. Okay, so the next is we are using liquids, right? So the liquids are density order will be 1 amp per centimeter cube. Okay, here same principle is going to happen. Whenever voltage rises, what is happening? The electric field is going to increase. Due to that, electrons are going to be multiplied. So that it will now the impedance will act as a transferring electrode. Okay, so that it occurs the breakdown. Okay, so that breakdown depends upon what means depends upon the pressure and the molecular structure of the liquid which we are using as a pure form of liquid. Clear? So I remember that last class what we have taught conduction and breakdown in two different methods. One thing is in the conduction and breakdown in pure liquid and as well as conduction and breakdown in the commercial liquid. So under commercial liquids I have told you all the mechanisms are there. Three mechanisms or four mechanisms are there. Four mechanisms. First mechanism we have discussed what it is. Multiple suspended particle mechanisms we have discussed. Okay, the second mechanism is what is calibration and bubble mechanisms. How this calibration and bubble mechanism, how this formation of vapor bubbles are obtained. Okay, first we have to know the reason for the obtaining of the vapor bubbles. The reason is the gas pocket at the surface of the electrode. This electrodes are there, and on the surface of the electrodes, what will happening? There will be some gaps. Okay, so under the during the gap process, what is happening? The gases are being generated. So that is gas pocket at the surface of the electrode. Also, complete reason for the formation of vapor bubbles. Okay. So the second reason is due to the electrostatic repulsive forces at the surfaces. Okay, what happening? Due to the electrostatic repulsive forces of the same here, the surface of the electrodes, again the formation of vapor on the surface. The third reason is gaseous products. Okay, when the gaseous products arises, we already said gaseous products arises due to the dissociation of ions. Okay, the same thing only we are repeating through the ionization process, or we can say the dissociation of ions. Who will arise? Gaseous product will arise. Okay, and the third reason is vaporization of liquid. When this vaporization of liquid comes, vaporization of liquids arises due to corona type of discharges. bubbles are formed. Okay, that was we are calling it as cavitation and bubble mechanism. So in cavitation and bubble mechanism, the formation of vapor bubbles responsible for the formation of vapor bubbles, the four things. One is the, we will say that as gas pocket at the surface of the electrode, and due to the second thing is due to the electrostatic repulsive forces at the surface of the electrodes, and the third reason is what? Gaseous product. Gaseous product arises due to the dissociation of ions, and the fourth reason is what? Vaporization of liquids. The vaporization of liquids at what condition it will arises due to the columnar type of discharges. Okay. So after these formation of bubbles, we have to calculate what is the breakdown voltage, right? So for that the formula is E naught is equal to, just we have to find study of the formula. No need to find it. Okay. So that is E naught is equal to 1 by epsilon minus epsilon 2 into 2 pi sigma. The sigma is the surface tension. We are seeing for what? For the liquids. Okay. So there will be a surface tension of liquids, commercial liquids. Under the topic commercial liquids will be arising. Vapor bubbles are arising. This bubbles filled with what? Air gaps. Okay. So then who will remain there? Surface tension will be there. Okay. You have been studying in your lower classes for the making and also so you have been studying that. During making of the soap, air bubbles arises. What is the purpose of the air bubbles and what we have to do to increase the air bubbles? All that is we have to study in lower classes. Okay. And so here E naught is equal to 1 by epsilon minus epsilon 2 into 2 by surface tension sigma into 2 epsilon 1 plus what is epsilon 1 and epsilon 2 here? In the previous suspended particle, we have seen the same permittivity. What is the permittivity of the liquid and other is the permittivity of the particle. That we have seen the suspended particle. Like this, particles means what there? Any fiber like dust or something. That you will remember or not? In suspended particle mechanisms, what does the particle means? I told you that any fiber or any, you can say that any fiber or any dust that remains in the water, okay, liquid. And the second mechanism is bubble mechanism. In bubble mechanisms, two permittivity comes under. One is the liquid's permittivity, same as that of the previous case, and other one is here what is happening. Vapor bubbles are forming. That is the gas bubbles permittivity, that is termed as epsilon 2. Okay. And the next is the bubble. What is the shape of the bubble? Sphere. Okay. So it is sphere shape. So we have to take the radius of that bubble sphere as r. Okay. And next is VP. That is the now the bubble is forming. Okay. So what will happen to that bubble? For all what we are doing on this process, what is the voltage drop due to that arising of bubble? That is VB is the voltage drop in bubble. Okay, so these are the things we need to identify and we have to find out what is the breakdown voltage during the case of bubble mechanism. Okay, so we have to explain the first conduction and breakdown in pure liquids, then the commercial liquids. Under the commercial liquids, we have seen four mechanisms. The first mechanism is due to the suspended particle mechanism. So the suspended particle have many fibers. So what is happening and how to break down voltage occurs? We are studying the formula. The second thing is we will be studying what? Bubble mechanism. So what is the reason for the responsible for my vapor bubbles? The four reasons. There are four reasons. Okay. After writing that, you have to note down what is that voltage, breakdown voltage. Calculate what is the formula, that is E naught. Okay. So over here sigma stands for surface tension. What is epsilon 1? What is epsilon 2? And the bubble is pure in shape, and we have taken the radius as r. And what is V suffix P? V suffix P is what? That is the voltage drop due to the formation of the bubbles. Okay. So after substitution, we will get to know the breakdown voltage P naught. Okay. So the next mechanism is thermal breakdown mechanism. Okay. So on the thermal breakdown mechanism, what will happen means now the temperature in thermal means what? reason what is going to happen means oil is heating up. What will happen is if you take as a transformer, conductors will be there. Primary side, secondary side. Okay. For cooling purpose, insulation purpose, what you are going to keep there? Oil. Since that oil is a medium, okay. Here if it's a air as a medium, the gap will fill with the heating. Okay, air will get heated. If gas is a medium, that will get heated. If oil is a medium, the oil will get heated. Okay. So if the medium is oil means what will happen? The oil will get heated. Okay, first what you are saying, temperature rises. Due to the temperature rising, what is getting increases? Current pulses are getting increases. Current pulses value is getting increases at the cathode surface. And due to that, what is happening? The medium between the two electrodes, some medium will be there. Any sort of dielectric or any cooling purpose liquid or oils. Cooling purpose liquid, no cooling purpose oil will be there. That will get what? Heated. So the heating of the oil will take place, and that is the reason for the formation of vapor bubbles. The oil gets heated means what will happen? Vapor bubbles will form. Okay. So now what? Here what we have to say for the formation of vapor bubbles? Due to the rising temperature, high current pulses form. The current pulses formed at the surface of the cathode. Next, what you have to say? That will heat the oil, and due to the heating, if the medium is oil, that is get heated. If the medium is gas, that will get heated. If the medium is any other electrons, it will get heated. Okay. So here we are saying heating of oil. So that what is happening? Vapor bubbles is formed. Okay. So the now vapor bubbles are formed. Okay. So that will fill the two electrodes gap. So bridging the gap between the electrodes. Now what will happen? Breakdown will occur. Okay. So the breakdown is occurring depends on what reason means depends on pressure and the molecular structure of the liquid. Okay. In between what medium we are placing commercial liquid means that will get heated. So the commercial liquid, if it is get heated means commercial liquid means it can be of any oils. Okay. Commercial liquid means it can be of any oil. That will get heated means what will happen? Vapor pressure, vapor bubbles will form. Vapor breakdown. Next the breakdown occurs, and the formation of breakdown occurring. The reason is pressure and the molecular structure of the commercial liquids. Clear? As a core mechanism is the oil mechanism. So what is going to happen? The oil is going to be the highest stress rate. Okay. So first breakdown strength depends upon what? The largest possible impurities. Or else we will be saying that the weak link. Okay. So when it will be weak, when it will be very weak, when there is an impurities. Okay. So breakdown strength is depends on what is largest possible impurities. Wherever the impurities are going to be present, that what is happening due to the reason breakdown is going to happen. Okay. Or else we can say that weak region. So or else we can say weak link. Okay. So the weak link is also the region, the minute traces of some impurities. Weak link means some traces of impurities. These are the reasons for which the breakdown is going to occur. Okay, now I am saying that breakdown strength. So you must know what is the breakdown strength, right? So the breakdown strength is the region which is stressed to maximum. Okay, when breakdown strength means up to higher level, up to what level the coil can withstand some amount of stress. Beyond the stress rate only what will happen? Breakdown will occur. I already told you. The range at which the breakdown occurs, that region is said to be the breakdown strength. Okay. Beyond that, if it rises, what will happen? Breakdown will happen. Okay. Beyond that, the current will get increases in drastically. Okay. So the withstanding property is breakdown strength. That is the breakdown strength is defined as the region at which the stress can be maximum. Okay. Beyond that means the breakdown will occur, voltage drop will arise, what will happen? Current will increases drastically. That is uniform electric field is arises. If the distance is larger between the two electrodes, we know what is going to happen. Ununiform electric field is going to happen. Okay. So in ununiform electric field, what does that breakdown voltage range will be? Okay. So the maximum range, I am saying that maximum there will be a range to get breakdown, right? Maximum voltage range at which the breakdown arises between the maximum into 0.9 times the maximum. Okay. Maximum into 0.9 times the maximum is the range between the breakdown occurring. It can be distance between that particular range. Okay. To read the continuation also. So next is the breakdown strength. So now the ரெண்டுக்குள்ள ரிலேஷன் தான் பார்த்துட்டு breakdown strength க்கும் oil stress ஓட volume. Okay, what is the relation? Both are equal proportion. If this stress volume is decreasing means breakdown will get increases. If this increases means breakdown strength will get decreases. Okay, can you able to follow? We are saying on the breakdown region, we are seeing the breakdown strength here. இவ்வளவுதான் தாக்கிக்க முடியும் அப்படிங்கிற அடுத்த அலைன்மெண்ட் பார்த்துக்கணும். So stress to volume, stress to oil volume decreases means breakdown strength will get increases. Can you able to imagine that? So the next is breakdown voltage. We are going to determine this breakdown voltage under three different conditions. Okay, what are the reasons responsible for it? Gas content in the oil. Okay, so the next is viscosity of the oil. How much it is dense, thick, or how much it is very thin. Okay, viscosity of the oil. The next is impurities that is present in the oil. Okay, due to that impurities only we is arising breakdown. Okay, so what is the relation? Both are inversely proportional means if the breakdown that is arising that is decreasing means oil stress will get increases. Okay, the two different observation we have. Okay, this is the graph between the breakdown stress as well as the stress to oil. Okay, you are clear with the core mechanism. You have to collect the criteria commercial liquid as well as for the pure liquid. Okay, after